Hello, today we're going to be looking at how to isolate a variable today. So specifically we're going to isolate the y variable, but we are going to isolate other variables besides the y. But mainly we're going to isolate the y variable to set it up in y equals mx plus b form. So we might want to, the first thing I always do is highlight what I'm trying to do. So I'm converting equation, so we're trying to convert y equals mx plus b, and we also are going to do cross multiplication to solve for a variable as well. So as you can see, it starts out with saying many linear equations are written in a form other than y equals mx plus b. For example, the standard form, and of course I believe we looked at this already, but I'm going over it again. So standard form of linear equation takes the form of this form of ax plus by. What does that mean? These forms can be converted to the y equals mx plus b form. And so, for example, here is a standard form. The 3 is the a. So this 3 right here is your a, and the 4 is your b, and the 12 is your c. And that's in standard form. We want to convert that to y equals mx plus b. So basically we want to solve for y here. The goal is to get y by itself on one side of the equation, since y is by itself in this form like this is called solving for y. Of course, we can say solve for x, and you would do the same thing. So I'm going to work on this side over here, write all the information on that side. The goal and the idea is to what I call unravel it's like peeling orange, unravel your variable to get to where the variable is by itself. So let's say, for example, we're solving for y. So let's say here is the equation we start out with. 3x plus 4y equals 12. So what we want to start, it says solve for y. So we want to get it into y equals mx plus b form. We're solving for y. And one way to approach this is, what do you look at y and you ask yourself this question. What's the first thing is done to y is to multiply by 4. Then after that you add 3x. Okay? So the last thing you did was add 3x. So you want to go in reverse of the operation. If you add 3x, that means you're going to subtract 3x. And the idea is that you have to subtract 3x from the other side too, because of the equal sign. The equal sign is very important. It says that because right now 3x plus 4y equals 12 says that this side is going to be 12 too when all is said and done. The x and the y, when you plug it in, it's going to be 12. It's going to add up to 12 when you multiply that times whatever x is and whatever y is. So this is the reason why you have to think of this in terms of your guiding your thinking, is that if you subtract 3x here from this side, that means there's 3x less on that side. So because of this balance thing, you have to do minus 3x on that side too as well. So that's the key here for doing this correctly. Okay, and I generally like to do this. So 3x minus 3x is 0. Of course, we can leave out the 0. You don't have to when you get used to it. And we still bring down the 4y. And of course, you cannot 12 minus 3x. You can't do that because 12 is not an x. So think of tiles. Remember when we went back to tiles? There's the number tile, so 12 is a number tile. So if you have the x tile, they're two different things, so you can't subtract them because they're two different things. So you want to put, because it's in slope-intercept form, you want to write 3x first, minus 3x, and then plus 12, like so. Okay, so we have 4y equals negative 3x plus 12. Okay, so now here, the last thing you did to y was multiply y by 4. So to undo that multiplication, you have to divide. Again, it's always the opposite operation. So you want to divide by y, or divide by 4, apologize. So here's the tricky part, okay? So do you divide by 4 to only one number? So do you only divide by this one or this one? Because the equal sign dictates, right? If you only divide by 4 partially to this one, it's wrong, or partially to this one, it's wrong. You have to do it to everything on that side. If you divide or multiply, it needs to be done to everything that's located on this side. So that's very, very, very important, okay? So that means that then we divide by 4 here and divide by 4 here, okay? So 4 over 4 gives us 1, and 1 times y is y. And then we have negative 3/4 x. And then we have plus 12 over 4. You can leave it as 12 over 4, but better yet is to say 12 divided by 4, which is 3, okay? So this is in y intercept form, or slope intercept, y-intercept form, because this is your slope and this is your y-intercept right here, okay? So that's how you solve for that. So okay, so now let's lock rotation, okay. So let's do these problems here. We are converting the following linear equation, so that means it's a straight line, into slope intercept form, this form. So we need to solve for y. So we have to get y on one side. So looking at this, y is not, there's no number in front of it, so the last thing we did to y was add 2x. So therefore we can subtract 2x from both sides. Or we can think in terms of tiles. There's 2x tiles here, and so 2x tiles here and 3x tile. So think of 2x over here, 2x plus x tile makes 3x and 2x, so 2x and 2x on both sides. Remember, doing the tiles, we can just cancel it out so that we don't have to deal with minus 2x. So, and there's a 2x and a 3x here, leaves us with 1x left, okay? So now we just have y is equal to x minus 7, okay? And so from there, it's in our slope-intercept form. So the question then is, what's your slope here? Well, there's a 1 in front you don't see, so that's your slope, and the y-intercept would be right here, your 7, negative 7 is your y-intercept. Okay, let's go to B. Let's try B here. You have x, there's 1x here, there's 3x here, so there's also 1x in that 3x. Leaves you with 2x left, so we can just cancel this x out, and then cancel this out, leaves us with 2x left on that side, so we have 2y equals 2x plus 4. Okay, so the last thing we did to y on this side is multiply by 2. So the opposite of multiplying by 2 to y is divide by 2. And remember, we have to divide through everything on that side. So divide by 2, divide by 2, divide by 2. We get y. 2 over 2 is 1. 1 times y is y. Y equals 2 over 2 is 1, so we get x plus, and 4 divided by 2 is 2. And there you go. Our slope is 1 again. You have to remember, you don't have to write a 1 there, but you have to know that the slope is 1 and the y-intercept is 2. All right. All right, here's the next one. So we have 3y plus 2 equals 2y minus 5x. Again, there's 3 y's over here and 2y here. We can cross 2y out of that one, and there's 2y here plus 1y makes 3y, so we can cross it out. Remember, using tiles, that was a technique we learned. So cross that out, leaves us with just y here, plus 2x equals, so we have y plus 2 equals minus 5x. And remember, we want to solve for y, so the last thing we did to y here is add 2, so we have to subtract 2. Okay? And so when we do that, we get 0. 2 minus 2 is 0, so we have y left here. And then we want to write, because 5, negative 5x, and minus 2 are, you have the negative x tile, and you have the negative 2, the 1 tiles, so those are two different things, so you cannot add them together to get like negative 3x or what have you. You can't do that. So you just rewrite what you have there, negative 5x. And again, we're putting in slope-intercept form. The x should go before the numbers. So this is what we get. Our slope is 5, and our y-intercept is negative 2. Let's go on to the next one. Here, let's distribute first. Here, like so. So we get 2y. Distribute means to multiply. So to the y first, and then to the 3. 2 times the y is 2y. 2 times the negative 3 is negative 6, equals 2x minus 6. All right, that's what we have. And again, so here's the trick again. Tiles, since the numbers are on the same, this one and this one are the same, we just cross them out, like so. And then we have 2x and 2y are not the same, because one is x and one is y. So what we have left is 2y equals 2x. Okay? Then we divide by 2. We get y is equal to x. Isn't that amazing? So what's our slope? Our slope is 1. What's the y-intercept? 0. So that means the line is going to hit the origin. So if this was a graph, so the graph would look, y equals x would look something like this, because the y-intercept is at 0 right there at that mark. So right there, that's where the y-intercept is, right smack at 0. So, but you don't see it. You see, you don't see it here. So it's like that, y equals x. Okay, the slope is 1, and the y-intercept is 0. Okay, you don't have to write it down, but that's what it is. Let's go on to the next one. Again, we want to distribute first before we do anything. And remember, you have to carry that negative through. Even if it's a minus sign, you have to think of it like a negative, because you can say plus minus a negative 3, and therefore you're multiplying, distributing a negative 3 into that quantity of x plus 1. Then you have 2y on this side, minus 3x plus 2. Keeping in mind, we're trying to solve for y. And so you have, notice, what do you notice? You have 3x on both sides, negative, so that means we can cancel straight out like that. And then, so what we have 5 minus 3 is 2. So we have 2 on this side. Then we have 2y plus 2, like that. And then notice, what do you have on both sides? 2, you can cancel that out. And then you're going to get 0 equals 2y. And y equals 0. So when you divide by 2, you're going to get y is equal to 0. So if you think, what? That doesn't make sense. You might say that doesn't make sense, right? So what is this saying? So think of a numbered line. So no matter what x I put in, y is always 0. So basically what you're getting is a constant that looks like it's, so whatever x I choose, y is always 0. So it's a line that hits the x-axis like this, y equals 0. This is y equals 0, like that, okay? It's tricky, that's a tricky one, okay? So let's go on to the next one. Again, distribute, this is another tricky one, because there's a 1 in front right here. So make sure you multiply by -1 inside that whole thing. So you're going to have x minus y minus 2 equals, distribute 4x plus 2, okay? And then we have, let's move x to the other side. Well, we can think there's 1x here. There's 1x here too, but that makes it 3x, okay? So we have 2, add 2 to both sides, and we're going to get negative y. And the reason we add 2 to both sides is to keep the equality, right? If you add 2 to that side, you have to add 2 to that side. So, and then what I did here, right here, you can just say minus x here and minus x here. Same idea, that's fine. But using the tiles, it just makes it easier. Whatever method you prefer for that sense, minus x, but because we learned about the tiles, how to cancel these out, we can just do it, cancel them out straight away without having to say minus x over here and then minus x here, okay? So now we have, that's going to equal to 3x plus 4, okay? So be careful that y has to be completely alone. That means no negative. There's a 1 in front here. You can think of a 1 here. And so that, therefore, you have to divide by -1 or multiply by -1. It doesn't matter in this case, but normally if there's a number in front, you're multiplying by -1, so therefore you divide by a -1. So if we divide by a -1, and again, you have to do it to everything on that side. That's the 4, by the way. That's going to change the sign, so we're going to get -1 over -1 is 1, positive 1. Positive 1 times y is y. And you're going to get -3x minus 4. So our slope is -3, and our y-intercept is -4. Okay? And then let's move this up. We'll solve for this one here. Again, this 10 was a mistake here. This 10 should have been, let's see, it should have been, I'll cross that out. That 10 should have been here, 10. Okay? So we have 2y minus 6 equals 4. The first thing we did to y was multiply by 2, and then the last thing we did was minus 6 to 2y, so that means we add 6 to both sides. Always the opposite. Then you're going to get 2y equals 10. Divide by 2, and you get y is equal to 5. Okay? We're solving for y this time. Just got to solve. Okay, so we got to be careful what we're doing. I thought for a second, I forgot. I thought we were putting it in slope-intercept form, but we're solving for y. Okay, so here we're solving for x. So we got to get x by itself. So what we need to do is, remember there's a 10 right here. So x gets multiplied first by 2 and then add 5y. So the last thing we did was add 5y, so we go in reverse and we do the reverse operation too. So the last thing we did, add 5y, so that means we're going to minus 5y to both sides. And then you're going to get 2x. 5y minus 5y is 0. And that's going to be negative 5y plus 10. Then the last thing we did is multiply x by 2, so that the opposite of multiplying by 2 is divide by 2. And you get x is equal to negative 5 over 2y plus 5. And that's what x is equal to. Notice it's not a number per se. It could be a number, meaning x equals some number. Sometimes x equals some equation on the other side. So when you isolate it. So it's not always for a number. When they say solve for x, you're thinking to yourself, I need to get a number. It's not always true. In this case, it's not true. But in this case, it's true that y was equal to some number. In this case, x was not equal to some number. All right, let's do the next one. Again, this belongs to over here. 2 plus 6x plus 10. Oh, that's pretty scrunched up. Let's make it nicer. Shoot. Okay, so 2 plus 6x plus 10. 2. Okay, on that side. So we're solving here for y. So 3 is multiplied to y, and then 6x is added. So the last thing we did was add 6x, so we minus 6x. Okay. And then, actually, we can't even do that yet because the y's aren't on the same side, so we have to make the y's on the same side. So you can do minus 3y on both sides, or you can do minus 4y on both sides. It doesn't matter. So I'm going to, because I don't want to deal with negatives, but it doesn't matter again, then it works itself out. I'm going to minus, okay, let's take care of this first, though, before we do it. So we get 0 from here, 6x minus 6x is 0, and then we get 3y here equals 4y minus 6x plus 11, okay? And then I'm going to minus, and then I'm going to, the reason I'm like, okay, I'm going to do this, 4y minus 4y. The trick is to get the y on, together on one side. So you're going to get negative y over here because that's negative 1y, or just plain y here. Negative 4y minus, or 4y minus negative 4y is 0. We get 6x here plus 11. And so then we get, gotta move that up a little bit. So we get, here, we have to take care of the, we're solving for y, so y is by itself, almost. We have to get rid of that negative, so we're going to divide by negative 1. And so when we do that, divide by negative 1, we're going to get negative 1, negative 1, negative 1. We're going to get y is equal to 6x minus 11, okay? And on this side, we're going to get, solving for x, we're going to get 6x, we're distributing, plus 12 equals, is that 2 plus 6x plus 10, so that's going to, 10 plus 2 is 12, so 6x plus 12. And again, this is nice, so what happens? They're the same on both sides. Remember what we did with tiles? So that means the equation is the same, okay? And so it ends up being 0 equals 0 because the equation, they're exactly the same equation. So no matter what value I put in for x, the number is always going to be the same. So if I put 2 in, it's going to be 12. So it's going to be, if I put 2 in for x, you're going to get 24. and the other side is going to be 24 too, so 24 equals 24. So when you get anything that's 0 equals 0, it does not matter what x value you put in, it's always going to be the same, okay? And then the last E and F. So we're going to have, so this M here goes to the other side here, minus, so minus M here on that side. And that M is going over here. We have Y, solve for X, okay? So what do we do to X here? Multiply by -3 and then add 6 to it. The last thing we did is add 6, so we're going to subtract 6. Remember, always the opposite operation. So we're going to get, again, don't get confused because we're not solving, we're not solving for y to set it up in slope-intercept form, but we are solving for x, okay? So then we have y minus 6 equals -3x, and the last thing that's done to x was multiplied by -3, so that means we divide by -3 everything. So we get x is equal to, you can write it in this form like this, or you can write it individually as a fraction that looks like this: -y over 3 plus, because it's a -6 over -3, it becomes a plus 2, okay? 6 divided by 3 is 2, or 6 over 3, which is 2, okay? So this is solving for x. So x is by itself, an equation on that side. Let's go for this one, solve for p. Again, we distribute, so we get m is equal to 8 minus 2p plus 2m, okay? We're solving for p again, so we want p by itself. So we're going to move 2m and 8 to the other side. So that means -8 minus 8. So we're going to get 8 here. Minus 8 is 0, and so you bring -8 to this side. And then you're going to get -2p plus 2m. Again, we're solving for p. So we want it minus 2m to both sides. Again, the reason being that you have to keep it equal because of that equal sign. Whatever you do to one side, you have to do to the other side. Keeping that in mind as you do the process. So we get negative m minus 8 equals negative 2p, okay? P is not by itself yet because of the 2, so what's the last thing we did to p? Multiply by -2, that means we have to divide by -2. And remember, this is a minus 8. So when we divide by 2, we're going to get p is equal to m over 2. And then plus, because it's -8 over a -2, it's going to be a 4. Okay? So this is our answer right here. P equals 4 plus m2. So if you prefer, you can rewrite it as P equals m over 2 plus 4. This is conventionally easier to say. This side is. Okay? All right. Oops, what happened here? Here we're solving for Q. Again, we're going to, let me lock this first. Lock this. Lock, rotation, okay. All right. So I'm going to make it bigger so you can see. Okay. And this x squared is actually over here. Plus x squared over here. So this is not here. So we're solving for Q. So distribute. You guys should know how to distribute by now. 4Q minus 32. 4 times 8 is 32, equals 7q plus 5. So I'm going to move q to this side, or we can just do minus q. Get the q's together, basically, before you do anything. So, because if we don't want to deal with negatives, oh, actually just do this. 7q minus 7q. We're going to get negative 3q. 32 equals 5. Okay. Then add 32 to both sides. Okay, you're going to get negative 3q equals 37. And therefore, q equals negative 37 over 3. Okay? That you can say negative 3, or you can bring that negative to the 37. So it doesn't matter here. This might look scary, but you're doing the same thing. You want to distribute first. And actually, you see the x's on both sides. You can do that magic power of cancellation. Remember what we did in the tiles? You can just cancel them out. So they don't exist anymore, so you don't have to look at them and make it so that, again, when you say you cancel them out, think about minus x squared on that side, minus x squared on that side. So when you do that, they become 0. So yes, that's why they cancel out like that. If they're the same on both sides, we can cancel them out. So we get 4y equals 6x. So I'm distributing in my head here. 2 times 3 is 6x. 2 times negative 6 is negative 12. And so you get minus 2x, like that. Again, we're solving for y. Combine the x's together, here and here. So we're going to get 4x minus 12. Get 4y, divide by 4. We're going to get y is equal to x minus 3. Voila. So we're going to do solving. I wonder what the x is there. Is that? Oh, okay. So we are solving portion using cross multiplication. This will become handy later on. So for example, what do we have? 30 example, 30x. What is that? Look funky to me. I'm not sure. Okay, so this would be, I'm assuming something was missing here. Oops. So here's what I'm going to assume, make an assumption here. And that is the original number was, the original fraction was, okay, I must have touched it. So the original fraction must have been 30, or up here, let's do it here. So the original must have been 30, and then like that equals, and the x is down here, and so 30x, and then 5 times 12, something like that. So you cross multiply 30 times x, you get 30x, 5 times 12, you get that, and then 30x, 5 times 12 is 60, divide by 30, you get 1, so you get x equals 60 divided by 30 is 2. Okay, so that's how you do cross multiply. So for example here, it's 10, so 10 times x is 10x equals 16 times 7. And then you're going to divide by 10. After you multiply the top, divide that by 10, you're going to get x is equal to, what's 16 times 7? 16 times 7, 16 times 7 equals 112. And you move it 1 decimal place, so it'd be 11.2. Okay? So that's what you should get for that one. That's A. And B, cross multiply this 6 times x, you get 6x. And then 15 times 3, which is 15 plus 15 is 30. So 45. So we're gonna get 6x equals 45 divided by 6, and we get x is equal to 6 times 45. Notice I'm not using an x to show times. We need to use either parentheses or bracket or a dot. Usually dot almost looks like 6.45, but so we have to be really careful where we write that dot. It can't be right on the bottom where the 6 is. So we have wait, no, I did something wrong. I apologize. I saw my mistake. So we get x is equal to 45 divided by 6. Does that go 45, 6? You see 7.5. Doesn't go in perfectly. You get a decimal point. The next one is 2x times 8, which is 16x. So 2 times 8 is 16x. Then 5 times 12 is 60. And then divide by 16. So basically cross multiplying is you're multiplying across like that. Okay? 5 times 12 and 2x times 8. I kind of took a shortcut here. I didn't show my work. So hopefully you can understand me and are listening. So we get x is equal to, what's 60 divided by 16? 60 divided by 16, we get 3.75. And that is all, folks. All right, hope you got something out of it, and I'll see you next time. Bye.